Hello everyone. In today's video, we are going to learn that how we can deploy a full stack AWS architecture using Terraform and ensuring the high availability in AWS. Okay, so in this blog, we will learn that how we can deploy the auto-scaling group with an application load balancer, EFS, RDS, Route 53, ACM, WAF, and the CloudWatch, like with this step by step. Okay, so here first of all I will explain you the overview of the architecture. Okay, so suppose we have a front end. Okay, so and if the user if hit the application, suppose we have the mobile application or we okay, so if the user hits like we can take an example. Suppose user hits and add to cart payment. Okay, so whenever he hits the first request will go to the AWS Route 53. Okay, so it will begin with the setting up your DNS using the AWS Route 53. It will direct traffic to your application, ensuring that the domain is name is resolved to the right resources. Okay, then Route 53 will send the traffic to the application load balancer, and the implement of the AWS load balancer will distribute the traffic eventually across your EC2 instances, and ALB also check the health of the instances and only route the traffic to the healthy zone. Okay, and we have secured the transmission using the AWS certificate manager, and it is very crucial for encrypting the data in transit and provides a secure channel of your users. Okay, then we are protecting our application. We have used AWS WAF to protect our application from the common web exploits that I will show you in the demo. And then we have elasticity with our the auto scaling. We are using auto scaling to maintain application availability and allow the number of EC2 instances to scale up or down automatically according to the condition we have defined. Also, we are using the EFS here, which provides a storage interface, which allows your applications to access the shared file storage. Okay, so we have automated this process via the Terraform, and from the user data script, we are mounting in the FS tab over there. Okay, and then laterally we have the database with the HA. We are using the in this demo we are using the MySQL. The Amazon RDS, we have master and the replica in the different AZ to ensure our database is highly available and the resilient to the infrastructure failures. Okay, and the last, not the last, we have the AWS CloudWatch, which will keep an eye in our application performance and set up the alerts whatever we have configured in the alarms. And then we have streamlined development our workflow using our the GitHub action. So we are leveraging the CICD pipeline using GitHub action to ensure our uh, or developers to they can change their code rapidly and they can create the infrastructure. And for this everything we are using the infrastructure as a code with Terraform, and we have written Terraform script to creation of all the services in AWS, which will deploy the entire architecture. Moving forward, let me walk you through the code that what we have created. So let me first start with the vpc.tf. So in the vpc.tf we are creating one VPC. Inside that we have one internet gateway, we have one NAT gateway, where we have one public subnet, and we have a private subnet. And according to that we are attaching the route table. After the creation of the VPC, we are also creating the Route 53. Here I have created the Route 53 zone with my DNS name, which is a code devops.cloud, and also we are creating the ACM certificate, and also we are creating the while certificate here as well, and we are using the cert validation here. And moving forward that here let's go to the rds.tf, and in the rds.tf you can see that we are creating one MySQL instance with the specific storage engine and engine class, and we are storing our MySQL password in the SSM parameter store, and here we are creating the separate security group for our RDS. And let's go to the EFS, and here we are creating one EFS and with the separate security group, and we are mounting to the our EC2 group. Let's come to the very important part here. Here we are creating the auto scaling group with the launch template, and here we are defining the launch template, where we are passing the IAM permission over here. Okay, here we are also touching the security group, and here we are adding the passing the user data. And along with the auto scaling group, we are also creating the one load balancer with the target group, with the health check, with the listener as well, and along with the security group. And here you can see that here we are creating our auto scaling group with the minimum size and maximum size. Here you can change your numbers according to your requirement. And here we are creating the CloudWatch metric alarm uh, with the our CPU utilization is went to 20% or 10%. We have, like, for the demo purpose, I have taken the threshold as 20, and the web CPU run down we have threshold taken the 10. And apart from that, we have one backend.tf where we are storing our Terraform tf state file. And here we if you go to the local.tf, if you can see local.tf, we are adding this 4 permissions to our EC2 instances. And in the provider.tf, we have defined the provider AWS, and we have also defined the Terraform versions, what version we have used for the AWS, for the random, for the template. And in the last, I will explain you staging.terraform.tf, where in this file we are using a map here, which is vpc_conf, and inside that we are mentioning the CIDR, DNS host name, DNS support, and along with that we are mentioning the public subnet and the private subnet CIDRs, along with the instance type AMI ID. And here we are defining the ingress rule and the egress rule of ALB of EC2 and the RDS. And here we are creating the one WAF. In the WAF, we are creating the rules to block these specific IPs, which I will show you in the demo. And let's go to the my terraform.yml file, which I have created for my GitHub Actions pipeline. So here you can see that here we are creating the jobs here, and here I have using the OIDC here. Okay, I have created one assume role where I have granted the permission. So here I'm not using the access key and the secret key. And here I'm using the Terraform init, plan, and the apply. Okay, so let's start with the one demo. So before starting the demo, let me hit the DNS code DevOps the cloud. Already we have opened this URL. So if I refresh the page, you can see that currently it is pointing to 2 servers. Okay, so which is 10.0.4.155 and 10.0.3.119 119 and 155. Okay, so we will block the my IP from the WAF to tell you that how the WAF is working. Okay, so let's check my IP, and we will copy this one, and let's go to the GitHub, and you go to the WAF section. And we can also parameterize this, and we can pass it from the staging.terraform.tf. So let's copy this and let's make it commit. Okay, and we can also run this pipeline manually as well. Okay, let's go to the action, Terraform. You can see that if you run manually, you can see that it will uh, written by like this, manually run by Vincing. Okay, let me refresh this page. Click here and let's click over here, and we will wait for the job for the plan and apply. And meanwhile, let's go to the WAF. WAF is already opened. Just click on the staging web ACL. You can see on the rule side. Okay, and here we can see block specific IP details. Okay, and from here we can also see that how many requests we are came here, and how many requests are blocked. Okay, so let's go to Terraform again, and we can see that IP has been changed. Okay, so let me refresh this page. Yeah, so you can see that our pipeline has been run successfully, and this is the output. Okay, so let's go over here and let's refresh this page. So you can see that currently we are getting the 403 forbidden. So in this way, uh, WAF can help you. Yes, so this is in today's video, and let me know if you need any other video, and if you like my video, please like and subscribe my channel. Thank you.